This video is going to demonstrate how to use the method of separating variables to solve a particular differential equation. Take this question as an example. We are going to solve the differential equation 32 plus x to the power 5 times dy over dx equals to x to the power 4 times cosine square y equals to 0 when x equals to 0. Solving a differential equation means we are going to find an expression of y which satisfies the differential equation. This differential equation can be solved by the method of separating variables. It is because for both left-hand side and the right-hand side, they are in the format of the product of the expressions for either x or y. What we can do here is to use some algebraic operations to move all the terms of y to the left-hand side, and then all the terms of x to the right-hand side. So for the next step, we can try to move the cosine square y from the right-hand side to the left, which becomes 1 over cosine square y. And then the bracket 32 plus x to the power 5 from the left, we can move it to the right, such that it becomes the denominator on the right. It becomes x to the power 4 over 32 plus x to the power 5. And then we have dy over dx on the left. As we can consider dy over dx to be a fraction, where for a fraction we can move the denominator to the right. Then for the next step, we can try to move the dx to the right, such that the right-hand side now becomes x to the power 4 over 32 plus x to the power 5 times dx. And then for the left-hand side, 1 divided by cosine square y, we can try to present this as secant square y. And then we still have the numerator dy here. We can try to add this integration notation for both sides, so that both becomes indefinite integrals, and we are going to integrate each of them one by one. For the left-hand side, integrating secant square y would becomes tangent y. And for the right-hand side, as this expression cannot be integrated directly, we have to consider the use of the substitution method. The denominator of this fraction is 32 plus x to the power 5, which can be considered as a composite function. Then we can try to refer to the substitution information here. We can try to let the small letter u equals to 32 plus x to the power 5, so that du over dx would be equals to 5x to the power 4. As we can consider du over dx to be a fraction, we can try to move the dx to the right-hand side, such that du equals to 5x to the power 4 dx. During the substitution, we can try to make sure that the right-hand side consists of the expressions of x only. So the coefficient 5 can be considered to be moved to the left-hand side, such that it becomes 1 over 5 times du equals to x to the power 4 dx. In order to apply this result, we would be able to substitute 32 plus x to the power 5 in the denominator by the small letter u, where the combination of x to the power 4 times dx can be replaced by 1 over 5 times du. So the right-hand side would become 1 over u times 1 over 5 and then du. Now we can see that both sides are ready for integration. So for the left-hand side, it would become tangent y. And then for the right-hand side, 1 over 5 is the coefficient. And then if we are going to integrate 1 over u, the result would become lateral log u. Of course, we can try to input the absolute sign to make sure that the expression inside the lateral log must be positive. And don't forget the last term, arbitrary constant. And as our goal is to find an expression of y in terms of x, we have to replace u by the expression 32 plus x to the power 5. In order to find the value of the constancy, we can try to do the substitution of the given initial conditions. As we are given that both x and y are equal to 0 for the initial condition, then the left-hand side becomes tangent 0. And then the right-hand side becomes 1 over 5 times lateral log absolute 32 plus 0 to the power 5 plus c. So that for the left-hand side, tangent 0 will be equal to 0 as the graph of y equals to tangent x passes through the origin. And then the first term on the right-hand side will be 1 over 5, and then natural log 32. So that we would be able to have negative 1 over 5, natural log 32, that would be equals to the arbitrary constant c. Therefore, we can try to substitute this result into the previous expression. We have tangent y equals to 1 over 5, natural log absolute 32 plus x to the power 5, and then minus 1 over 5, natural log 32. And then if we wish to cancel the tangent ratio on the left, we can try to take the arc tangent on the right hand side. We will be able to have y equals to arc tangent. And then for the right hand side, we can try to factorize by taking 1 over 5 as a common factor. And then we still have natural log 32 plus x to the power 5 minus natural log 32. We can also apply one of the laws of logarithm. Natural log a minus natural log b becomes natural log a over b, so that our final expression can be presented as natural log of the absolute sign, where 32 plus x to the power 5 will be in the numerator, and then 32 will be in the denominator.